students, my name is Nitesh and Shet. I am from Manavara. So last class we discussed about a topic from 8th standard, that is algebraic expression and identities. In algebraic expression and identities we already discussed about algebraic identities and some of the types and like terms and unlike terms. Also we discussed about operations on algebraic expression. So let us move on to the next topic, that is identities. Identities or identity. So identity, we have an identity card. That means it is unchanged. No change we are taken it as. So here identity means here in the particularly in the algebraic expression. So here whatever the algebraic expression we have, we already know that monomial, binomial and whatever the expressions we have. So in the first video, we already discussed about the addition of some like terms. After that, we have a result. So that means when we equate those two things, when we insert any value of x or any value of y, the LHS side and the RHS side is equal. So that means there is no change at all. The LHS side and the RHS side must be equal. So these things we are called as a identity. So for example, I will take the first it is any other expression you can take. So here x plus 3 and x minus 2. So here both are the binomials. It's a multiplication of two binomials here. So we already learned that one. The multiplication of two binomials also we learned. So for first one we have in both the things we have to consider, one is the monomial and then another one is the binomial. Then we have to do the operations between monomial and binomial. We already learned that. After that we get some result, that is x square plus x minus 6 we have. After the result we have this one. So they just look like this completely a algebraic expression. Before it is a two binomials. Here it is a trinomial we have. So but here equality sign is there. That means you can put any value of x to this equation, there is no change at all. That is LHS and RHS both are same. So that equations are, we call it as the identity. So let us check that one. So let us take x is equal to 1. When we take x is equal to 1, here 1 plus 3 into 1 minus 2. So in place of x, I just substituted the value of 1 here. That is 1 square plus 1 minus 6. Yes, then here 1 plus 3 it is 4 into. Here 1 minus 2 is minus 1 is equal to 1 plus 1 minus 6. Minus 4 is equal to 4 into minus 1 is minus 4. Then 1 plus 1, 2, 2 minus 6 is minus 2. Here just observe LHS is equal to RHS. Here LHS is equal to RHS we have. Then, so let us take another problem, another equation. X is equal to, I will take x is equal to minus 2. X is equal to minus 2 you can take here. Yes. So minus 2 plus 3 and minus 2 minus 2 is equal to here minus 2 whole square. Minus 2 whole square plus of minus 2 minus 6. Here minus 2 plus 3 it is 1 into minus 2 minus 2 it is minus 4 is equal to, then minus 2 square it is 4 minus 2 minus 6 is equal to minus 4 is equal to minus 4 minus 2 2 minus 6 minus 2. Here also we get minus 4. Let us take any other number. X is equal to 0. Let us take x is equal to 0. Yes, 0 plus 3 and here 0, 0 minus 2. 0 minus 2 is equal to 0 square it is 0 and x is equal to 0, 0 and 0 plus minus 0. And here it becomes 3 into minus 2 is equal to 0 minus 6. Here 3 into minus 2 minus 6 is equal to minus 6. Here also LHS is equal to RHS Here also we have LHS is equal to RHS. So that means here just observe LHS is equal to RHS, here also LHS is equal to RHS, here also LHS is equal to RHS. So whatever the value of x you can take, so the LHS and the RHS, those two are equal only. If it is the equation is 2. So such value, such equality holds for all the values of x, then this expression we are calling it as a identity. So there is no any change at all. The result is very clear. It is those two are same only. That is such an equality. Such an equality true for every value of x, then the algebraic expression is known as identity. So here when we have this value, so that means here x plus 3 and x minus 2 is equal to x square plus x minus 6. This is the identity. We can use whatever the term we have, whatever the number, we can insert the value of x. So that one is true. So let us take some of these standard identities are there. That means we can use for solving some of the problems. So let us take standard identities. So apart from these identities, we have some of the standard identities. That means sometimes we have a multiplication of a binomial, so it requires much time. So when we have a formula, when we have identity, so we can easily find out the result. So let us take the first standard identity, that is a plus b whole square. A plus b whole square we have to take. Sometimes we have 2x plus 3y and 3x plus 4y. So likewise, binomials are there. We have to multiply twice. So at that time, so we have to multiply with the binomial and binomial. Sometimes we have to take one of the binomial as a monomial. We have to multiply. So likewise, it consists some of the time. It having some of the time. So that's why for that one, so here we have identity. It will be very useful to solve those type problems. Yes. So here we have to solve and comes into the standard identity form. Yes. So here a plus b whole square. Square means the multiplication of two identical terms. That is, let us take like that. So a plus b into a plus b. Yes. So let us take those things. Here we have to solve these things. That is a plus b into a plus b. Here we know that the multiplication of two binomials. So what we have to do? So consider one of the binomial as a monomial and another one as a monomial. So here one is the monomial, another is the binomial. We have to take like that. So here I will take this one, a plus b as a monomial. This one is a binomial. That is, firstly we have to multiply this monomial with the first term of the binomial. That is a into a plus b plus. Here it is a plus. Then b into a plus b. B into a plus b is equal to. Here monomial with the binomial. Here we have to multiply with the first term a into a plus here a into b plus here b into a plus here b into b is equal to a into a square plus here I will take ab plus here ab into a is there. So that means we can write a into b. So it is both are same because commutative property. That is a into b. So we can take ab directly is equal to b square. So plus b square so is equal to a square plus ab plus ab. So 2ab plus b square. That is a plus b whole square is equal to a square plus 2ab plus b square. It is very important. So here it is very important identity. You have to remember, you have to recall, so you have to know this one. Otherwise you can't get the mark. Sometimes you have to multiply these type of problems with the help of standard identities. Then you have to insert this formula. So that's why it is very important formula you have to remember. Yes, so this is the first algebraic identity. So here when we have the binomial, so followed by the plus sign, addition sign. So simultaneously we have some of the binomials we have followed with the negative sign. So let us take that one. This is the second identity, that is a minus b whole square. A minus b whole square. Similarly we have to take that one, a minus b into a minus b. Here also we have to consider the same thing, that is one of the binomial we have to consider it as a monomial, and another one we have to consider it as a binomial. Here it is a monomial, it's a binomial. So let us take that one, a into a minus b, similar steps, and followed by the minus sign, and b into a minus b, b into a minus b. Here is a minus sign, it is followed. Then here a into a square minus a into b, ab, minus b into a, so b I will write, then minus of minus plus b square is equal to a square, minus ab minus ba. So we can take this as ab also, that is minus 2ab plus b square. So because ab is equal to ba, here also we have to write ab is equal to ba. So this is a minus b whole square. So this is the another standard identity. So it is very important to us for the examination point of view. So here there are another two identities are there. So we have to discuss in the next class. So here there are two identities are there. With the help of these two identities, we have to solve some of the problems. So let us take some of the problems. So let us take the problems based on these two standard identities. So here there are two forms of questions are there for each standard identity. So here I am taking the a plus b whole square. So here just observe, it's an algebraic expression type problem. So here also it is 2x plus 3y whole square, that is a plus b whole square form it is. And another is numerical form, that is 103 whole square. So here it is algebraic form and here it is numerical form. So those two are also solved with the help of identities. So here firstly we have to take here it is 2x and 3y is there, 2x plus 3y whole square is there. So we can use a plus b whole square, that is a plus b whole square. So we have to write, you have to write the identity in every problem. That is a plus b whole square is equal to a square plus 2ab plus b square. Then here, so we have to insert the values. Here just observe, in place of a we have 2x, in place of b we have 3y. That is here a is equal to 2x and b is equal to 3y. We have to insert in this identity. That's why we have 2x plus 3y whole square is equal to here. So we have to careful about that here. So in place of a you have to substitute 2x completely. So that is 2x whole square. So whole square you have to write here. Don't write 2x square. It is wrong. When you write only 2x square, it is wrong. So it is only belongs to the x only. But here you have to take completely. So then plus 2 into, in place of a you have to insert 2x, in place of b you have to insert 3y. Then plus, in place of b we have to insert 3y here, so you have to insert completely with the bracket sign, that is 3y whole square. As then is equal to 2x whole square means here we already know that, so here 2 into x both are there, we have to multiply both, so here you have to take that one. So here 2 square is 4 and x square is remains as it is, x square. then plus. Here first you have to multiply with the constant term. That is 2 into 2 4, 4 into 3 12, 12 and again remains xy. Plus here 3 square is 9, y square remains as it is. That is 2x plus 3y whole square is equal to 4x square plus 12xy plus 9y square. So it is very easy to calculate in very small interval of time. So we can complete this problem with the help of this identity. Yes, so let us move on to the next problem. It is 103 whole square. So here just observe, we can write it as 100 plus 3. 103 is 100 plus 3, so we can write it. This 103 is equal to 100 plus 3 whole square. So consider 100 plus 3 whole square. It's in the form of a plus b whole square. So here in place of a we have 100, in place of b we have 3. That is a plus b whole square is equal to a square plus 2ab plus b square. So here what we have to do here? Here we have to insert 100 in place of a and 3 in place of b. So that is a is equal to 100 and b is equal to 3. That is 100 plus 3 whole square is equal to, so in place of a we have to write 100. 100 square plus then 2 into a into b. In place of a we have to insert 100 and in place of b we have to insert 3 plus b. In place of b we have to insert 3 square is equal to 100 square is 10,000 because here 2 zeros are there. After squaring we have 4 zeros. That is 1, 2, 3, 4. So after 1 we have 4 zeros. Then plus 2 into 3 is 6. 6 into 100 600 plus 3 square is 9. So we have to know all the squares up to 28. So that's why we have to learn that one. Yes. So here we have to take, so you can write individually. So that 10,000, then 600, then 9. You can take like that also 9, 0, 6, 0, 1. That is 10609. That is 103 whole square. Yes. So within a small time, so we can easily find out 103 whole square with the help of this identity. A plus b whole square is equal to a square plus 2ab plus b square. So here it is the sum of the problems. So what are the types of problems we have? In case of using standard identity, a plus b whole square is equal to a square plus 2ab plus b square. So let us move on to the sum of the problems based on a minus b whole square. So let us take the problems based on the second identity, that is a minus b whole square. Here also there are two forms of the questions, that is first is the algebraic type, another is the numerical type. So we have to solve both here using a minus b whole square is equal to a square minus 2ab plus b square. So yes, so here just observe here 7a minus 9b whole square we have. So it is in the form of a minus b whole square. A minus b whole square is equal to a square minus 2ab plus b square. So in place of a we have 7a, in place of b we have 9b. So that is a is equal to 7a and b is equal to 9b we have. Then in place, so we have to substitute a 7a in place of a and this 9b in place of b. So let us take that one. 7a minus 9b whole square is equal to, in place of a we have to insert 7a completely because it is a square. So we have to take bracket sign. That is 7a whole square minus 2 into, in place of a you have to submit 7a and in place of b you have to write 9b plus in place of b we have to write 9b whole square. Yes. So is equal to 7 square it is 49 a square minus here. So 7 into 2 14. 14 means here 126. 14 into 9 it is 126. 126 AB. Then plus 9 into 9, it is 9 square is equal to 81 B square. So that means here it is 7A minus 9B whole square. Then, so here we have the answer for this first question. Then let us take the next question. Here it is 9.8 whole square. It is not 98 square. If it is 98 square, so then we can take 100 minus 2. 100 minus 2 whole square. But here it is 9.8 whole square. So that we can take it as a 10 minus 0.2. 10 minus 0.2 whole square. That is 10 minus 0.2 whole square we can take here. That is, so here it is in the form of a minus b whole square. A minus b whole square. Then a minus b whole square is equal to a square minus 2ab plus b square. Plus b square here. So then substitute the values. Substitute the values here. Yes, here 10 minus 0.2 whole square. Here in place of a we have 10 and in place of b we have minus 0.2. So here 10 square. A square is a 10 square minus 2 into 10 into 0.2. That is in place of a we have 10 and in place of b we have 0.2 plus 0.2 whole square. Yes. Then, so here it becomes 9.8 whole square is equal to 10 square is 100 minus 2 into 10, 20 or 10 into 0.2 means 2. 2 into 2, 4 plus 0.2 whole square. 0.24 whole square, how can we take that one? So just imagine, so 2 square is 4 here. 2 square is 4. That means when we multiply those two decimals, 0.2 into 0.2, 0.2, here we have 4 like that. But here when we have such thing, here, so here we have 2 decimal. After 2 decimal we have decimal point. So that's why we have 0.04. 0.04. So this is equal to 100 minus 4. 100 minus 4 is 96 plus 0.04, that is 96.04. That is 9.8 whole square is equal to 96.04 is the answer. So here we have to be careful about that one, 0.2 whole square, and after that we will taking the next steps. So this is the problems are based on a minus b whole square is the second identity of standard identities. So in next class, so we have to take the next 2 identities. So there are many problems are there. One is the numerical type, another one is the algebraic type, and another is the numerical type. So you have to understand. Here it is also possible, that is 9 plus 0.8 whole square. So from that one we can use a plus b whole square also. The answer will be the same. So you have to take the right steps. So this is about the first two identities, standard identities. So those who are watching this video for the first time, please subscribe our channel and don't forget to press the bell icon. You can get the notification very easily. Also hit the like button. Thank you and all. Be safe and stay home. Thank you.